here is our question 4, and just by looking at this, there is a lot more going on the left hand side, so we're going to simplify that. The answer that we're looking for is what is on the right, so we need to get cos x over sin x. Let's start off by writing down what the left hand side is equal to. So here's what we have. Now the first thing I notice here is that we've got a tan x in the denominator, and we can replace tan x with sine over cos. Let's keep all our other terms the same as is for now, and the only thing we're doing is replacing tan x with sine x over cos x. Okay, so here we have it. Just to show you, I have replaced this tan x with sine x over cos x. But now, there's something interesting that we notice in the denominator. We now notice that in our two terms in the denominator, we now have common terms. Notice that in the first term, as well as the second term, they both contain 2 sine x. So we can pull out 2 sine x from the denominator as a common factor. Let's do that. So the numerator is going to stay as is, but in the denominator, we are taking out 2 sine x. Now in the first term, since there's nothing left in the numerator, we're going to have 1. So that becomes 1 over cos x, because remember the cos x is still there at the bottom. And in the second term, we've got minus cos x that's left. What you notice now though is that the 2 sine x that you've pulled out as a common factor can cancel out with 2 sine x from the numerator. So the 2's cancel out, the sine x from the bottom cancels out with 1 of the sine x from the top. So at the moment, in your numerator, what you're left with is just sine x. Now when you have a look at this denominator, so this bracket that was left, we are subtracting 2 fractions with the different denominators. Remember, this negative cos x is a fraction because it's actually over 1. So let's work towards getting this to be 1 fraction. Now to get it to be 1 fraction, what we do is we multiply both denominators together. So cos x times 1 is cos x, and then we cross multiply. So we're going to have 1 times 1, which is 1. We keep the minus in between and we cross multiply the other way. We have cos x times cos x, which is going to be cos squared x. Now based on what you're left with, this part specifically, 1 minus cos squared x, I want you guys to notice how this comes from your identity. Sine squared x plus cos squared x is equal to 1. If we manipulate this identity, we can get it to look like 1 minus cos squared x. We can keep the 1 on the right hand side and we can take the plus cos squared x over to the right, so it becomes negative cos squared x. On the left, what we're left with is sine squared x, so we clearly see that 1 minus cos squared x is equal to sine squared x. So replacing it, here's what we have. We have sine x all over sine squared x over cos x. Now I know that when it comes to working with fractions within fractions, it becomes a bit confusing, especially if you are not good with the laws of fractions, but there's always an easier way to do this. This, however, is going to be part of your rough work, so you're going to do this on the side. This will help you to simplify this fraction. So here's what we do. We write down the numerator. We write our main division line, or our main fraction line, as a division sign, because after all, fractions represent division. And then we have our second fraction, so that is sine squared x over cos x. So we had sine x being divided by this fraction. Now you learned in primary school that if you are dividing 2 fractions together, your next step is to change the division into a multiplication. What happens when you do this? Your second fraction gets inverted. So your second fraction gets swapped around. Second fraction now becomes cos x over sine squared x. At this point, you are allowed to cross cancel. Cross cancel means if any of your numerators and denominators are the same, they can cancel out with each other. Now we notice that is what we have because we've got sine x. It can cancel out with one of the sine x from the bottom. And ultimately what we're left with from these fractions is just cos x in the numerator and sine x in the denominator. So that is our next step. This entire fraction has simplified to cos x over sine x. And if we have a look at the right-hand side in the given question, that is actually what they needed. So now we can conclude and say that it is equal to the right-hand side. Please remember to like, subscribe, and turn on your notifications for more content.